नाही सर.
Okay, we'll wait for 1 minute. बघूया अजून कोणी जॉईन होतं का बघूया. We'll wait for 1 minute, okay?
ओके सर.
ओके, यस्टरडेच न्यूमेरिकल जे घेतलं होतं होमवर्कसाठी दिलं होतं टी सेक्शन, त्यासाठी आपल्याला स्पेसिंग फाइंड आउट करायला सांगितलेलं होतं. For yesterday's numerical, answer for moment of inertia, or before that, y bar is equal to 157.5 mm. Please write down the answer. Please try to solve the yesterday's homework numerical. I will be 60.125 into 10 raised to 6 mm fourth. Then, as we discussed, that is for flange only. So Q nil, that is for flange, is equal to AY bar. So it will be 345,000 mm cube. Then Q nil, the formula for Q nil is V Q nil by I, where V is taken as 2 kilonewton. So Q nil, after simplify, we'll get 11.476 Newton per mm. Jay,
यस सर.
कालचं केलं सॉल्व प्रॉब्लेम?
थोडं ट्राय केलं तर वाय बार काढता आलं नाही.
Y bar 157.5 येतं.
बघतो सर, आताच जॉईन झालं इथं.
ठीक आहे. These are the answers. Please write down and please cross verify. Please write down the answers for yesterday's homework numerical and please cross verify. Check and please, we will discuss in next lecture also. Okay, so Q nil is equal to 11.476 Newton per mm. So So as I told in last lecture, find out Q nail, then we will find out the spacing between the two nails. Okay, so for that, after the Q nail, write down each nail will take a shear force, of V nail is equal to Q nail multiplied by spacing. Yes, that we will find out. So V nail is given, that is V max is 500 Newton, which is equal to 11.476 multiplied by spacing between the two nails. So maximum spacing we will get 43.57 mm. Okay. This is the maximum spacing between the two nails. Okay. So please cross verify your answers and we will discuss in next lecture regarding Y bar I if it is not matching with the given answers. Okay, so shall I proceed now?
Yes, sir.
Right. So now we will discuss the shear center, that is shear numericals on shear center. Numericals on shear center. We have to find out the shear center. Okay, take down first numerical. Determine the shear center E for the cross section given. So the I section is given, but this section is like this. Okay. So from center of this to the center of this, distance is given B. So this distance is given H1. This distance is given H2. Force is passing through this point O. Force is P, and this distance is nothing but shear center E. E that we have to find out. Okay. And all the segments having thickness is T. All the segments having thickness is your T. Okay, shall I proceed?
Yes, sir.
Right. Now we have to find out the value of small e for the given section. So for that, we have to find out we have to use the equation of summation of m is equal to all the forces multiplied by the E. Okay. So by using that equation, okay, we have to find out the value of E. So for that, we require the shear flow distribution for this section. We require the shear flow distribution for this section. Then in each segment, we have to consider the separate force, right? In each segment is nothing but the two flanges are there, and the right and left part of the force, that is P. ठीक आहे, दोन फ्लॅंजेस आहेत, त्या दोन्ही फ्लॅंज मध्ये आपण एक फोर्स कन्सिडर करता येईल. ओके, लेफ्ट फ्लॅंज मध्ये एक फोर्स, राईट फ्लॅंज मध्ये एक फोर्स, आणि जिथं तुमचा पी फोर्स अप्लाय झालेला आहे, ओके, लेफ्ट ऑफ दिस अँड राईट ऑफ दॅट पर्टिक्युलर पी फोर्स, we have considered the force in that particular web. Okay, that is shear flow. So that consider, and from that we will find out the I, then Q, then force. As we know, in last lecture we have taken the numericals. In that we have used the equation shear flow is equal to VQ divided by I, where Q is equal to AY bar, and if you have to find out the force due to shear flow, we have to find out the force due to shear flow is nothing but integration of Q into dx or ds. Okay, that also we have taken one numerical in last lecture. So, and next equation that you have to use now is summation of m is equal to force into eccentric E. Okay, that is sum of moments of shear center. It is called as sum of moments of shear center. Summation m is equal to P into E, right? Where P is nothing but the force which is applied, right? So from that we will find out the value of E, right? So these are the equations that we have to use while finding out the shear center. Okay. So now first step 1, identify force required, identify force required for summation of m is equal to P into E. Okay, so for that we will draw the shear flow distribution for the given section. Draw the section. We will show the shear flow. Then shear flow distribution. Point O is here where the P force is applied. So shear flow will be like this. We will discuss in last lecture also. And left of P and right of P. Okay, this will be the shear flow distribution. Shear flow distribution. Now we have to consider the each part, two flanges and the left part of the force and right part of the force applied, that is left part from point O and right point O. Okay, all of it wrong. So we will consider now the force in each part. All of you drawn?
Yes, sir.
Right. So next, again, please draw the section again. So we will consider the one force in this part, one force in this second floor part, then left of this and right of this. Suppose we will take the reference point A. Okay, we will take the reference point A. Suppose the force is your, this force is your FW1. This force is supposed taken as FW2. Then this is your force P. And if this force is taken as FF1 and this force is taken as FF2. So we will consider the force in each part. As we have placed the point A as a reference point for E, as we have taken the A as a reference point for E, and we will take the sum of moments. We will take the sum of moments about point A, right? Can I proceed now? All of you drawn? Shall I proceed?
Yes, sir.
Right. So now I will clear this diagram, but you have to remember the diagram, or I will keep as it is. But there is no, okay. So right now, we place A, point A as a reference. We place point A as a reference for E, the shear center, comma, and we will take sum of moments about point A. Okay, if you're taking the moment about point A, then FW1, FF1, FF2 are passing through A. Is it correct? FW1, FF1 and FF2 all are passing through point A, right?
Yes, sir.
So moment due to these forces are nothing but equal to moment due to these forces. We are taking the moment about point A. All are passing through point A. So moment due to these are forces is equal to
0.
0, right? 0. So there is only one force, that is FW2, which will cause the moments. Okay, remaining R will cause the 0 moments. right? So next line. In this case, FW1, FF1, FF2 will have zero moments about point A, right? So we will now take only FW2. So we only need to solve for FW2. Right? All of it, shall I proceed? Okay. The next, step 2. Now we will find out the moment of inertia. Calculation of moment of inertia. I. So again, we will take this I section. Please draw the I section. Then this will be the neutral axis. Distance from center is given as B. This is your H1. This is H2. Okay, suppose this is part 1, second part, and this is your third part. Thickness for each is your T. Okay, now we will find out the moment of inertia. Okay, shall I proceed?
Yes, sir.
Now, if you consider the moment of inertia, okay, that is part 3rd, that is for wave. So the thickness is very small. Thickness is very small. If you take that particular, that is 1/12 BT cube, T is very small. So we will neglect that particular moment of inertia for part 3rd. Okay, it is 1/12 into BT cube, right? So T is very small. So for that, we will neglect that particular thing. So whatever the moment of inertia for part 3rd is nearly equal to 0. As T is very small, so we will not consider that. So that is equal to 0. So we will take the moment of inertia for part 1 and part 2. Okay, so right now, as T is much smaller than other dimension, write down, as T is much smaller than other dimension, so I3 is equal to 1/12 BT cube. So it is nearly equal to 0. As T is very small, so 2 cube is also very small. So that equal to 0. That equal to 0. So we will take the moment of inertia for part 1 and part 2. So write down I is equal to I1 plus I2 plus I3. I3 is 0. So I1 is equal to 1 by 12 T into H1 cube plus 1 by 12 T into H2 cube, right? So I is equal to, after simplification, T by 12 is common, H1 cube plus H2 cube. So this will be the moment of inertia. Okay. Yes. Or Dana?
Yes, sir.
Right. Now we will find out the value of capital Q is equal to AY bar. Stepwise. I झालं कॅपिटल क्यू नंतर स्मॉल क्यू नंतर मग तुमचा summation of m, that equation we will take. The next step 3, calculation of capital Q is equal to AY bar. Capital Q is equal to AY bar. Now, which force we have taken, that is FW2 in this part. बरोबर आहे ना? मोमेंट अबाउट ए घेतल्यानंतर इथला फोर्स निघून गेला होता, इथला फोर्स निघून गेला होता, फक्त हा एक फोर्स राहिला होता. येस ऑर नो? FW2, राइट? Yes or no?
Yes, sir.
Right. So we will consider only this way. We will consider this part only. Half flange फक्त आता आपण consider करणार आहे. Okay, because the force in this member only we are consider. बाकीचे जो part आहे त्यामधला force आपण consider करत नाही, कारण moment due to that force about point A will is equal to 0 येतोय. So we will consider the force in this part, that is FW2. So we will consider this part only. So as we were discussed in last class, okay, if you are finding out the force is equal to Q into ds, right? Q into ds. So for that we will consider this part, and for that we will consider the small portion for the integration limit. So we will consider this small portion, right? And suppose up to the center, suppose this distance is nothing but it is y bar. Okay, thickness is your t. Thickness is t, and this distance is nothing but s2 divided by 2. And suppose this distance we are taken as y. Right? So y bar from neutral axis is 2 by 2, and this small hashing portion having dimension is y into t, or you can take x also, or y. Okay. right? So we will consider this part. Similarly, there is another part is here also. Okay, so this again the same. So whatever the q is equal to ay bar, that you have to multiply by 2. That you have to multiply by 2 because we can split this into two equal parts. Okay, lower and the upper region, both are equal. So we will consider only this part, upper part, and that we have to multiply by the 2. That we have to multiply by 2, right? Okay, diagram draw केला.
Yes, sir.
Okay, next line. Around. In this case, we only need the Q, capital Q, for the second flange. Okay, so we can split it into the upper and lower part or region. Both are equal, which are equal. Then calculate the Q and multiply by 2, right? So in this case, we will need to find out the capital Q for the second flange. So we will split into upper and the lower region, and which are equal. So while you calculating that, you have to multiply by 2. Okay, now we will find out the Y bar. So next line, Y bar is equal to yes 2 by 2 minus Y plus Y by 2. Correct? बरोबर है कि नहीं? Yes, correct or not?
Yes, sir.
Yes, sir.
Right. So after simplifying, yes 2 minus Y divided by 2. That is Y bar. That is Y bar. So now next we have to find out the capital Q. So capital Q is equal to 2 times AY bar is equal to 2 times in bracket Y multiplied by T multiplied by Y bar is your S2 minus Y by 2. So after simplification is equal to Y into T into 2 get cancelled. S2 minus Y. So what is the range of Y? Y starts from 0 here and up to neutral axis it is h by 2. So Y limit is 0 to Y is equal to h2 by 2. right? So now we will find out the shear force, that is nothing but FW2. Shall I clear this? Shall I clear?
Yes, sir.
Next, step number 4. So use the equation V is equal to integration of Q into ds. So V is nothing but, now we will consider FW2, force in that particular, and Q W2 into dy. So is equal to integration of y is equal to 0, y is equal to h2 by 2, and q is nothing but vq w2 divided by I into dy. Okay. So now by putting the values, FW2 is equal to integration 0 s2 by 2 v by I. We are putting the value of q is nothing but y into t into h2 minus y into dy is equal to v by I common into t is also common, integration of 0 s2 by 2 y into s2 minus y dy is equal to, now take the integration, s2y minus y square by 2, sorry, y cube, wait, we have to multiply it in bracket, then we will take s2 by 2, s2y minus y square dy. Next line is equal to Vt by I, then h2 y square by 2 minus y cube by 3, 0 s2 by 2 is equal to Z of W2 Vt by I h2 cube by 8 minus h2 cube divided by 24 is equal to Vt by I into s2 cube divided by 12. Okay, so this is the value of your FW2, that is force in the second flange. Okay, understood? Can I proceed?
Yes, sir.
Right. So now, next step, step number maybe 5. Right? So as I told you, have to use the equation moment about A is equal to P into E. Okay, so now next line. Now taking the moment of FW2. FW2 into B is equal to P into E. Okay, FW2 is acting in this flange and somewhere point A is here. From this we have taken the distance from center, that is B, like this, right? So FW2 into B is equal to P into E. So now put the value of FW2, Vt by I, H2 cube by 12 into B is equal to P into E. Now we have to substitute P is equal to shear force, that is V, and I, moment of inertia, value is known to you, T by 12, H1 cube plus H2 cube. This I is already we have calculated. So substituting P is equal to V, that is shear force, and I is equal to T by 12, H1 cube plus H2 cube in this above equation. So now I, that we have to put the value of I, T by 12, H1 cube plus H2 cube, and is equal to V. So we get cancelled. I think 12 get cancelled. So remaining is E is equal to B H2 cube divided by H1 cube plus H2 cube. So this is the value of your shear center. Understood?
Yes, sir.
So it is simple. Whatever the section is given, for that we will consider the each part separately, right of the force applied P and left of P. Then consider the force in each part. Then assuming one reference point where we will take the moment. So you have to take the moment at such a point where you can cancel the maximum forces. So we have taken the reference point A where the three forces having moment is 0. So remaining is only FW2. So now for FW2, we will start taking the moment. For that, we will require moment of inertia. Then we require capital Q, that is AY bar. So the force in second flange is there only. So for that only we will consider the second flange for calculating the capital Q. So after Q, then force is equal to integration of the small q into ds. So we are putting the values, then we will find out the FW2 because we will require this FW2. So after calculating FW2, put the value of P is equal to V and putting the value of I, you will get the shear center for the given section. काय अडचण आहे याच्यामध्ये कुणाला?
No, sir.
Okay. 1 minute. Now we will take the next numerical. Second numerical. And determine the location of shear center determine the location of shear center E for the given figure. So it is channel section is given. Section is given like this. Point O is here. Force is applied. So this distance is nothing but your shear center E. This force is P. Then the dimension from the center B. Then this is your H1. This is again H1. And the total thickness is again same. Okay. Left drawn, shall I proceed now? Now solution. Again we will draw the shear flow distribution diagram. Okay, first step. Step 1, identify the forces. Identify the forces required for summation M is equal to P into E. Identify the forces, that is similar way that we have taken for the last numerical. Now the shear flow distribution diagram. So shear flow will be like this. Okay, this is your shear flow distribution. Oh, all of you drawn? Shall I proceed?
Yes, sir.
Now, again, we will take the reference point. Reference point A is here. Again, we will take the reference point. कारण का आपल्याला एक रेफरन्स पॉइंट पाहिजे जिथं आपल्याला मोमेंट घ्यायचं P इंटू E, राईट. तर ह्या प्रत्येक पार्टमध्ये काहीतरी शेअर फ्लो असेल, शेअर फोर्स असेल. ओके, त्याचा आपण कुठे मोमेंट घेणार आहे? पॉइंट ए ला, दॅट इज रेफरन्स पॉइंट. आणि त्याच पॉइंटला तुमचा P इंटू E मोमेंट येणार आहे. समेशन M इज इक्वल टू, ओके, moment of shear center is equal to P into E. So whatever the P into location of shear center E about A is equal to काय असेल? या प्रत्येक पार्ट मध्ये जे फोर्स असेल, शेअर फ्लो असेल, त्याचा मोमेंट घेणार आहे अबाउट पॉइंट ए. So for that we have to identify the forces. Now we will consider the each part separately. So suppose this part, okay, we will take the force is suppose is FW1. Then force in this part is your suppose EFF. Then the force in this part, okay, again redraw the diagram. Then the forces, suppose this is were taken considered as EFW1. Suppose this we will consider EFF. Then it is same EFW1. Then it is also same like upper part EFF. And suppose this were taken as FW2. Right? So force in each part. तर हा एक पार्ट आणि हा एक पार्ट सेम असल्यामुळे फोर्स सेम घेतोय. हा पार्ट आणि लोअर पार्ट सेम असल्यामुळे फोर्स सेम घेतोय. राईट. अंडरस्टूड. लक्षात येते ना काय करतोय आपण.
Yes, sir.
राईट. सो नाउ Aaron, we place point A as a reference point. Reference point for calculation of E, and taking sum of moments about point A. तर पॉइंट ए ला आता मोमेंट घेतोय. तर इथं जर बघितलं तर पॉइंट ए मधून F_W2 फोर्स पास होतात, त्यामुळे त्याचा मोमेंट किती असेल?
0.
Zero. Right. So remaining is only F_W1 and F_F. Remaining is your F_W1 and F_F. So we will consider the moment of these two forces, F_W1 and F_F. So for that we will consider this part. Okay, similar way this part, because force in this will cause the moment about point A, right? So next line diagram. In this case, one minute. Okay, I'm audible.
येस सर.
राईट. मी आज ग्रुपवरती एक टाकलेलं आहे निर्मिती MITचं. बघा एकदा चेक करा, जर झालं तर बघा पार्टिसिपेट करा. तुला प्राइज मनी पण आहे. झालं तर बघा, वेळ असेल तर तुम्ही ट्राय करू शकता. पेपर प्रेझेंटेशन आहे, कॅड आहे, टेंडरिंग आहे, भरपूर इव्हेंट्स आहेत. ऑनलाईनच होत आहे ते शक्यता. ठीक आहे.
ओके.
चालेल. So now FW2 will pass through the point A, so it will cause the moment is 0. So remaining is F and FW1, so it will cause the moment. So now we will consider these two forces only, FF and FW1. तर वरच्या पार्टमध्ये जो आहे तो सेम फोर्स खालच्या पार्टमध्ये घेतला आणि इकडचा जो पार्ट आहे तिथं सेम फोर्स इथं पण घेतलेला आहे. ठीक आहे, बिकॉज इट इज क्रॉस सेक्शन इज सिमेट्रिकल. राईट, लक्षात आलं?
येस सर.
राईट. नाउ वी विल फाइंड आउट द मोमेंट ऑफ इनर्शिया. आता फोर्स तर माहीत झाले, कुठले फोर्स आहेत, कुठल्या पार्टमध्ये फोर्स आहेत ते माहीत झाले. नाउ वी विल फाइंड आउट मोमेंट ऑफ इनर्शिया, देन फाइंड आउट द कॅपिटल क्यू. Okay, for each part, then we will find out the FF and FW1 by taking the integration. Right? Similar procedure. Next step, step number 2, calculation of moment of inertia, MI, that is value of I that we have to find out. Okay, the neutral axis will be like this. So we have taken the dimension, the dimensions are given. Center to center is your B, is your H1, this is your H1 also, total is your H. Right, so consider this part is first part, this is again first part, this will consider second part, this will consider third part. Thickness for each element will be same. Thickness is T, it is having thickness is T, this is also T. Okay, so now I will write down directly the equation for the moment of inertia. So write down I is equal to I1 plus I2 plus 2 times I3 plus A H square. H is nothing but the part third. Okay, so is equal to that 1 by 12 T into H cube minus 1 by 12 T into H minus 2H1 cube. This is your I1 plus 1 by 12 TH cube. This is I2 plus I3 again 0. I3 is again 0. So A into H square, that is A into B into T into H by 2 square. So I is equal to TH cube by 6, sorry, plus BTH square by 2 minus T into H minus 2H1 cube by 12 of return. Shall I proceed? Shall I proceed?
Yes, sir.
Right. So after simplification, I is equal to T by 12 2H cube plus 6BH square minus H minus 2H1 cube bracket close. This is the value of moment of inertia I. Okay. Left written. Now next step number 3. Calculation of capital Q is equal to AY bar. So we have two forces, FW1 and FF. So for these two forces, we will consider the QW1 and QF. Okay. So in that first Q for FW1, okay, please draw the diagram. So now we will consider this part. This will be the neutral axis. Thickness is T. We have taken this is as Y. Up to center is Y bar. This is your H2 or H1. This is H by 2. Okay, so Y bar is equal to H by 2 minus H1 plus Y by 2. Correct? Eh? So Y bar after simplification, you get 1 by 2 H minus 2H1 plus Y. y bar is equal to half into h minus 2h1 plus y. So next line, q w1 a y bar is equal to t into y into t into y bar half into h minus 2h1 plus y. So after simplification is t by 2 hy minus 2h1y plus y square. This is the value of qw1. So range for y is, for this case, y is 0 and y is equal to h1. Range for integration, right? 0 to h1. Understood?
Yes, sir.
Right. Now second. B. Q for FF. Now we will consider half of the portion. So consider, suppose this is your X, thickness is your T, Y bar, suppose Y bar 1, you may call Y bar 1. So it is next line, y1 bar is equal to h by 2 and y bar, sorry. So consider this complete portion now. So y2 bar. So y2 bar is equal to h by 2 minus h1 plus h1 by 2. So is equal to h minus h1 by 2. So next we will find out QF. QF is now summation of both the part. Shall I clear this?
Yes, sir.
Next line, QF is equal to summation of a y bar is equal to a1 y1 bar plus a2 y2 bar is equal to h1 into t into h minus h1 by 2 plus x into t into s by 2. So QF is equal to t by 2 h1 minus h1 square plus chx. This is the value of QF, and x is start from x is range is 0 and x equal to b. Okay, 0 to b. लक्षात आलं? Yes or no?
Yes, sir.
So today we have meeting at 3 PM. जर सरांची मीटिंग आहे तर राहिलेला पाठ आपण उद्या घेऊया, चालेल ना?
Okay, sir.
फॅकल्टी मीटिंग आहे 3 वाजता. आता काय आपल्याला फोर्स एफडब्ल्यू आणि एफ इंटिग्रेशन झालं की मग समेशन ऑफ एम अप्लाय करायचं, राईट?
Yes, sir. Got it.